Hi everyone, this is a video on assigning oxidation numbers. Oxidation numbers, sometimes we call them oxidation states. The main thing about them is they're integers. They can be positive or negative, but no decimal places allowed. Integers. We have a handful of rules that we can follow when we're talking about assigning oxidation numbers to individual substances, whether they're simple ions, elements, or in a compound. Elements, 0. A metal by itself, sodium, magnesium, calcium, 0. Non-metallic elements like O2 or Cl2, 0. Simple ions, an anion or a cation like a sodium ion, Na+, the oxidation number is going to match the charge. So if we see an ion and it has a charge of +1, its oxidation number is +1. If we see an oxide ion with a charge of -2, well then its oxidation number is going to match the charge and also be -2. If we see oxygen in a compound, it's going to be -2. We're going to use that all of the time. Hydrogen in a compound, +1. Likewise, we're going to see that all of the time too. Very exceptional and a little bit strange. If we see hydrogen in a hydride, that means where the hydrogen is bonded to a metal, the hydrogen in that case is going to be -1, but that is quite rare. The sum of all of a substance's oxidation numbers is going to correspond to the overall charge. So if we have a polyatomic ion, like say these nitrates over here with a charge of -1, all the oxidation numbers together will add up to -1. If the compound has no charge, like here I have sulfuric acid, then all the oxidation numbers there would add up to 0. I have these examples. We're going to go through and assign an oxidation number to each element in all these different situations. Okay. Starting with water. We have 2 hydrogens and an oxygen. There's no charge on the water. These oxidation numbers are going to add up to 0. Look at what we have. Oxygen in a compound, doesn't matter if it's an ionic compound or a molecular compound. Oxygen's -2. Hydrogen in a compound, +1. The hydrogen in this compound is +1, and the oxygen is -2. There's 2 hydrogens, 1 plus each, and the oxygen has an oxidation number of -2. And those all add up to 0. I have nitrate ions next. Oxygen is -2. Oxygen is -2, but there's 3 oxygens, -2, -2, -2. The total of the oxidation numbers for just the oxygen is -6. We have 1 nitrogen, and the oxidation number of that nitrogen in combination with all those oxygens, they're going to add up to -1. So the nitrogen here is +5. The nitrogen is +5. Oxygen is -2, but there's 3 of them, -6, and a +5, all add up to -1. Next I have sulfuric acid. That's a compound. Oxygen is -2, hydrogen is +1. We're going to see that so many times. Hydrogen is +1. Oxygen is -2. But there's 2 hydrogens, makes +2. There's 4 oxygens, that makes -8. So whatever number the sulfur has here is going to set it all up so that the sum of all of those numbers is 0. The sulfur here is +6. Hydrogen is +1, but there's 2 of them, so that makes +2. The sulfur, if it's +6 and there's 1 of them, that makes +8 in total, the 2 hydrogens and the sulfur, and 4 oxygens, each at -2, -8. The sum of all of that is 0. We have no charge for the sulfuric acid. I have sulfur as an element, S8. Oh, sulfur as an element, elements are 0. 0. Oh, so sometimes sulfur maybe is +6. Here it's 0. The oxidation numbers of different substances are going to be fluctuating all of the time. We're not going to get a standard kind of answer. Here's nitrogen +5. In a different scenario, it could be +2 or 0. There's a whole range of possibilities. Same with sulfur. The two main factors that are going to show up over and over again is that oxygen's -2 and hydrogen's +1. There's an exception here for the hydrogen, but pretty much it's always going to be +1. One final example before we move on. These carbonate ions, CO3, 2-. Oxygen's -2. Oxygen's -2. There's 3 of them. That makes -6. We have one carbon, and its oxidation number is going to be something that makes the total -2, 2 negative. So the carbon here is +4. One carbon at +4, 3 oxygens at -2 each. When we add all of that up, we get -2, which is the charge of this polyatomic anion. So, assigning oxidation numbers, always an integer. No decimals, could be positive, could be negative. We have some rules to follow. We're really going to lean heavily on these two ideas, oxygen being -2 and hydrogen being +1. The sum of all of those oxidation numbers equals out to the charge. -2 might be neutral or even -1. All adds up to correspond with the charge of the chemical. And I hope that helps.